let's understand it. So I'll start with the basic statistics today. All right. And then we will go for, we'll quickly learn what is sigma, how to calculate standard deviation. Then how standard deviation is impacting the quality. That is something which we are going to learn. And how the process capability without using Minitab. Okay, we are going to learn how we can do that, right? And this is going to be very, very important session. So the first principle is more variation, more rejection. Write this down. More variation, more rejection. This is a first principle. More variation, more rejection. So why Lean Six Sigma is so important? Because we are basically attacking on the variation part of it. Okay. So Six Sigma basically attacks on the variation, the variability part of it. Yeah, let me just put my AC. Yeah. Okay. So more variation, more rejection. So if we reduce the variation, see, variation cannot be eliminated. It's a principle of the universe. Variation is a very integral part of the universe. You cannot eliminate the variation. Okay. Now, for example, let me give you a simple example on this. Now, example, let's say there are two pens. I've got these two pens, which are basically manufactured. Okay. Now, when I say variation, it is applicable in every industry, by the way. It's not only manufacturing or automotive or this and that. It is applicable in IT industry, applicable in service industry, insurance, banking, every BPO, every industry. Okay. Now, let me give you a simple example on this. If imagine there are two pens I have. Okay. Let's say this is pen number 1 and pen number 2. And I want to measure the diameter of this. Okay. I want to measure the diameter of these two pens. Now I'm talking about variation. Okay. How it is so important. So let's say I take the measurement with vernier scale or screw gauge, and then I will measure 10.1. Second, also 10.1. So you will say, see, I was talking about it is exactly same. So variation does not exist. Then if I increase the resolution of that, let's say 10.12, 10.12, still the same, still the same. But if I go further, it will be like this, 10.124 and 10.126. Are you understanding? So at the level, the third digit, you are finding the variation. If you are not able to find the variation, it's a limitation of the scale, but variation has to be there. Are you understanding? Just type yes in the chat box. This is a very important principle. Try to understand this. Variation is nature of nature. You cannot variation from the universe. Variation has to be there, but by using statistical tools or Six Sigma, you can reduce the variation. Why you should reduce the variation? Because more variation, more rejection. Clear? First principle clear hai why we are so much behind variation. Because it's very simple. More variation, more rejection. More rejection, more losses to the company. More wastage of money. Are you clear? This is very, very important. If the two of are from same manufacturers, the same plant, exactly. Not even same manufacturer, same plant. If it is made with the same person, same shift, same machine at the same time, still it will vary. Same raw materials, everything is same, still it will vary. If it does not vary, it's a limitation of the scale. And so variation has to be there. It's an integral part of the universe. It's a universal principle, just like law of gravity. You can't change it. Okay, clear hai? So first funda clear. So variation is an integral part of the universe. More the variation, more the rejection. So our entire focus is on rejection, variation reduction. Through variation reduction, we are going to reduce the, the rejection part of it. And if we save the rejection, lot of cost of poor quality, lot of losses can be saved, and that will increase the profitability. See, why do we do business? Why our business exists? Type in chat box in one word. Type in chat box. Why is our business existing? Type in chat box quickly. Let's go into the fundamentals of it. Then, why do we even exist? So existence किसके लिए है? Yes. Anybody working for a non-profit organization? Yeah. A lot of people say we are here for for making cars. We are here for giving the banking service. We are here. These are all the means to achieve the profits. Are you understanding? Yeah. So these are all means. We only exist. The business exists to earn profits. Very simple. Okay. Customers, products, services, markets are the means to achieve the goal, which is profit. And rejection reduces your profit. Very simple. Why Lean Six Sigma certified people are hired in high numbers? The only reason is we can improve the profitability by reducing this cost of poor quality. Okay. Now coming back to the basics. So some basic statistical thing we will cover quickly. Okay. And then we will go to how this standard deviation sigma is impacting our, the quality and the process capability, etc. Okay. Chalo. So to understand that, first we need to understand statistics. What is statistics? Very simple, plain vanilla statement of statistics. The definition of statistics is statistics is a science which converts data into information. Very simple. Okay, statistics is a science which converts data into information. We have data. That data does not mean anything to us unless and until that is converted into a meaningful information, which makes sense. Because if I give you tons and tons of Excel sheet data, that will not make any kind of sense, and your brain is not wired to infer anything out of it. Understand this? Okay. So statistical science which converts data into information. Now, statistics has two important legs, two important parts. Okay. One is descriptive and other is inferential. Now, descriptive is nothing but about the, I always give this example of a cricket match, which I always love. Okay. So when we see a cricket match, in the cricket match after 5 overs, when we see the score like 30 runs, 1 wicket after 5 overs. Okay. That is called a descriptive statistics. A description of the sample of 5 overs. That is called descriptive statistics. And apart from that, just as we are looking at that score, below that there is a line of projected score. Let's say it is a T20 match. Okay. Projected score. So you will see 150 runs or 160 runs or 170 like that. If they play with, let's say, 7.5 runs per over, they will go to 150. If they play with 8 runs an over, they will go to 160. If they go to 8.5 runs per over, they'll score 170 runs. So this is something which we have, which is a projected score. Now understand this. 5 over is a subset of 20 overs. Understand this. This is called sample. And 20 over is the entire population, because the entire population contains all the data points. Okay. And so projected score is nothing but about the population, and it is called inferential statistics. Sample, it is called descriptive. For population, it is called we are inferring from the sample of the descriptive statistics. We are inferring about the population. It is called inferential statistics. Are you clear? There are 2 types of statistics, descriptive and inferential. Descriptive is about a sample. It is about the past. And inferential is about the population, is about the future. It's a prediction about the behavior of the population. Clear, everybody? Just type C in the chat box. C is clear. Especially the new people. The seniors have heard this 50 times. And why they have heard? Yes, inferential is about the population. We are predicting the behavior of the population. If they are scoring, let's say, if they are scoring 5 overs, 30 runs, So they will score 120 runs if they maintain the same run rate. If they score with 6 runs and over, if they score with 7 runs and over, they will go to 140. It's a prediction about the population. Okay. Now, when it comes to descriptive, there are two things again. One is called a central tendency and other is called a dispersion of the data. What is central tendency? Central tendency meaning every data set, every data, whatever data we are collecting, there is a center of the data. Okay, that there is a central tendency of the data, which is measured by mean, mode, and a median. Okay, now if I draw this, if I draw a normal distribution curve, which is basically coming out of a histogram, correct? When we will do the what you can say Minitab exercises, we will see this. Okay, so this is called the center of the data. Okay, and this one is called the variable dispersion or the spread of the data. Clear hai? So this one is the center and this is the spread, and both are important. Both are important. Understand this? Okay, both are important. I'll show you why both are important. So central tendency is measured by mean, mode, median, and dispersion is measured by range, variance, and standard deviation. All right, and just talking about inferential statistics, process capability analysis, hypothesis testing, regression, design of experimentation, all these are inferential statistics. Okay, are you clear? So this is it clear? Just take a screenshot of this if you are taking the notes. Just take a screenshot of this. By the way, this what you can say, this PowerPoint presentation is available in your Greenbelt curriculum itself. Okay, and every hackathon we cover this. We speak about this for almost 20-30 minutes in the hackathon. Okay. Yeah, dispersion is the is the spread of the data. For example, all right. The dispersion is measured by range, variance, and standard deviation. Standard deviation, which is sigma, is also a measure of dispersion. For example, everybody, can you just put your height in the chat box quickly? Your height in centimeters. Okay. If you are aware of your height, can you just put your height in the chat box? Can you just do this quickly? Just for our understanding. Okay, 182, 64 or 164? 61 or 164 hoga. Okay, 178, 176, 180, okay, 179, 170, 170, 182. Fantastic, fantastic. A lot of tall people in the room, huh? Very nice. Okay, so understand. So we have somebody like 150 centimeter. Let me just type in. So we have somebody at 150, we have somebody at 185. Are you understanding? So this is the spread of the data. So if I plot it on the histogram, it will be like this. So let's say, for example, if I only take people, above 6 feet height, so above, let's say 180 centimeter above. Okay, if I only take them, then the data will be like this, very, very narrow. But if I take all the people sitting in the room, the data will be like this. Are you understanding? So the spread will be very high. Okay, so this is what is the dispersion all about. The spread of the data is called dispersion. Clear? Just type yes in the chat box if you're clear about it. Super clear, everybody? Yes, very nice. Super. Okay. So, and why spread is important? So, you will be shocked to understand this. Okay. Why both these aspects? Why central tendency is also important and why dispersion is also important. Okay. Now, let's look at this. So, yahan tak clear hai. So, let's touch upon mean, mode, median, and then the standard deviation calculation we will do. Okay. So, descriptive inferential hum log ne dekha hai. So, let's come to mean. What is mean? Mean is nothing but the arithmetic average. Simple arithmetic mean. Okay. Which is adding all the data points divided by number of data points. Very simple. Okay. So mean is average. Very simple. So everybody knows it, right? Take the collect the data point and take the average of that is called the mean. So it's a one type of central tendency. Okay. Mean, average. Second is called mode. Okay. Second is called mode. Mode is nothing but the maximum frequently occurring value. Okay. Now in this data set, can you just observe closely and tell me which data point is coming most frequently? Type in the chat box. Senior people know everything, huh? सीनियर पीपल इमीडिएटली उनको तो बाय हार्ट हो गया ये। उनको नींद में भी पूछेंगे तो हाँ सर 75 वो पता है हमको। Can you please show me the mean sheet? Okay, Nipun, we will share this entire document. It is there in your green belt. I'll show you where it is, everything. Okay, all these things, your green belt curriculum only I'm showing. Yeah. Okay, so which data point is maximum frequently occurring, which is 75. So 75 is, so this is 1, this is 2, this is 3. So 75 is called the mode. Mode is the maximum frequently occurring value. Okay, so if I draw so this value, this frequency is called the mode. The highest peak, okay, it's called mode. Okay, now then what is, uh, yeah, again, if there are, let's say, if there is 80, if I add 80 here, okay, so here you can have 75, 75, 75 three times, right? Now, if I add 80 here, I will have 80, 80, and 80 also three times. So in this case, what will be the mode? So right now, if I added another 80, so in that case, what will be the mode in this case? Try to understand this. Think about it. No mode, 77.5, both 80, add off 2 and then divide by 2, which is average, like, okay, bimodal. Okay, good, 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 good. Okay, it's fantastic. So when we have two equally, frequent modes, so that is called bimodal distribution. What is that? Bimodal distribution. Okay, so it looks like this. It looks like a camel back. Okay, bimodal distribution, or sometimes it is multimodal distribution as well. Anything which is more than bimodal is called multimodal. But generally, you will not find such kinds of scenarios if we follow some sampling strategies. Okay. Now, apart from that, now imagine a scenario where all the data points are only occurring once. Then what will be the mode? The definition is maximum frequently occurring value, right? If the data set is happening only once, then what will be the mode in that case? Type in the chat box. So it will be like this. Every data set will be coming. So this is first, right? So this is 0, this is 1. So every data set is occurring only once, like this. Just like our teeth. Just like our teeth. Yes? So it is called uniform distribution. Write this down. It is called uniform distribution. This is also not the normal distribution. Huh? Uniform distribution is different than the normal distribution. Normal distribution has the mean is equal to mode is equal to median, and they are at the center, which is like this. So mean, mode, median are at the center here. Okay, that is called normal distribution. So this is called uniform distribution. Clear hai? Everybody, are you understanding this? Just type yes in the chat box. Are you getting this idea? Just type yes. Okay. Yeah, if you have been through this, this will be a revision. Now, if you are already a green belt or black belt certified person, just look at this as a trainer's point of view, how you can explain this concept to my subordinates. Okay. Now, then the third concept comes is median. Median is a central value. If I arrange the data set in ascending or descending value, what comes in the center? Okay, look at it. This is the data set. If I arrange the data set in the ascending order, okay, this is the data set arranged in the ascending order. So 19 comes in the center. So 19 is my median. Okay, 19 is my median. Now, so the immediate question comes that if mean is there, then why this median is required? Okay, the mean is already there, right? Mean is what? The average of that, right? Which is the central, and majority of us, we use mean only, right? We take the average quickly. Whatever, any mathematical calculation, statistical calculation we have to do, we take the average immediately, right? Then why is median required? The answer to that is, let's say, there are people, I'm just giving you a very simple common example, try to understand this. If I take the salary of the employees of the company. Okay. Let's say if I take 5 people salary and the salary goes like this, 7 lakh rupees per annum, 9 lakh rupees, 12 lakhs, 15 lakhs, and let's say 16 lakhs. Okay. Now everybody pull out your calculator. Pull out your calculator. I've just randomly put some number. Okay. In the ascending order. So here, tell me what is the mean? What is the mean of that? Calculate the mean and type in the chat box. For this 5 data points, what is the mean? Everybody, pull out your calcs and tell me. What is the mean? Is it 12? 12 नहीं आएगा ना? ये आपके कैलकुलेटर में कैसे वेरिएशन हो सकता है? 11.5 हाँ 11.8 हाँ अभी अभी बराबर है. Mean has the disability not to measure very high low value the data. Yes, very good. Now, so mean is 12. What is median? No, sorry, mean is 11.8. Sorry. Mean is 11.8. Correct? What is median? 12, right? Which is central value. Correct? Everybody? Clear है? यहाँ तक clear हो गया everybody? Just type yes in the chat box. Clear? Yes? So this is the salary of let's say executive or let's say middle level management people. Okay. Now, if I add salary of CEO into this, now the CEO salary is 100 lakhs, for example. Okay. So if I write again, and if I add 100 lakhs, which is 1 crore per year. Okay. Now tell me what is the mean? Tell me what is the mean of this? Calculate this. And what is the median? Mean क्या है? 26.5. What is the median? हाँ मीडियन में थोड़ा सा फंडा अलग है. ओके. मीडियन में थोड़ा सा फंडा अलग है बिकॉज लेट्स से दिस इज अ डेटा सेट. ओके. Because this is odd data set, so we have only one central value. Correct. Let's say if I add some 8th data point, so you have to take average of these 2 data points. Okay. So you have to take average of 19 and 25, which is let's say 22. Okay. Now in this case, you have to take average of 12 and 15, which is 13 and a half. Everybody clear about this? Now, what is your observation? Type in the chat box. What have you observed with this example? What have you observed with this example? Type in the chat box quickly. What is your observation in this example? There is 2 median. हाँ 2 नहीं, इसका एवरेज लेना है. There will be only 1 median. You take average of these 2. 12 and 15 का एवरेज लेना है. Okay. So if you observe very closely, this is a outlier data. Yes or no? Understand this. 100 lakhs is an outlier data. Yes or no, everybody? Because if you take the average employee salary, it is around 12 lakh rupees. That's the average executive or middle level management salary. Okay. If you add CEO salary, it is the odd man out salary. Yes or no? It's an outlier salary. Now my mean immediately gets influenced because of the outlier data. But my median, if you observe very closely, it has not got hugely influence. Yes, it has got influence, but not hugely influence. From 12, it has just gone up to 13.5. Not very high. Understand this. So mean gets influenced very easily with the outlier, but the median does not get influenced with the outlier immediately. Understand this. Okay. That is the reason whenever we have normal distribution, write this down. whenever we have normal distribution, we check mean of the data. And when we have non-normal distribution, or we call it as skewed distribution. Okay, I'll show you that. Non-normal or skewed distribution, then we have to check median of the data. Are you clear? That is the reason we check mean as well as median both. And if there is a distance between mean and median, that is an indication that the data might be non-normal. Okay. For example, this is a normal distribution, a symmetrical normal distribution. And this is a non-normal distribution where mean, mode, median are different. Are you clear, everybody? Just type yes in the chat box. Are you learning something new? Some new concept? Understood some new concept? Just type yes. Superb, superb. Very nice. Now, so this is the central tendency part of it. Now let's come to dispersion. Now we have talked, we spoke about what? Mean, mode, and median. This is the central tendency. Let's speak about the dispersion of the data. Okay, how the spread of the data can be measured. The first measure of the dispersion, which is the spread of the data, is the range, which is simple as highest minus lowest value. Simple. The first, and this is a very primitive way of measuring the data. Okay, the tallest person in the room and the shortest person in the room, you take the difference. That is called the range. Very simple. The heaviest person in the room and the lightest person in the room, you take the difference. That is called the range. Very simple. Yes, it's a very simplest one. Now let's calculate the standard deviation manually. Okay, with this simple example, we will calculate manually standard deviation. Okay, so this, which is a very important. See, we are going to be Lean Six Sigma, right? So let's calculate sigma. Okay, we'll take 5 minutes, but we will, that concept will be very, very clear. Okay. Now, the first step to calculate standard deviation, which is again a measure of variation or measure of dispersion, I would say. The first step is collect the data, right? So collect the data. Let's say we have 10, 12, 15, 18, and 20. Let's take a simple data set because we want to calculate it manually. Just pull out your calculators. Okay. Then you take the average. So average will be very simple. 10 plus 12 plus 15 and all. And then it will be 75 plus 75 divided by 5 is equal to 15. So 15 is our average. Okay. Now, once you've taken the average, now why are we taking average? Because average is that reference point from which we will calculate what is the distance of each and every data point from that. It's a reference point for us. That's why we collect the average. Okay. So first we collect the data, then we take the average. So average is our reference point. Now from the average, we will calculate a deviation. Now what is the deviation? Deviation meaning the distance from that average value. The distance from that average value of each and every value, by the way. Okay, it's called deviation. Now, can we calculate a deviation here? Deviation is the distance from the average value. For example, 10 and 15. Let's say this is the first data point, right? This is the first data point. So what is the distance between this and the average? Type in the chat box. What is the difference between 10 and 15? What is the deviation? Type in the chat box. Everybody. No, 10 and 15. 10 and 15. 15 is the average. No, we have taken the 15 as average. So what is the deviation? Is 5. But I would rather say it is minus 5. Because it is minus 10 minus 15, right? It is minus 5. Are you clear? Okay. Now, what is the difference? What is the deviation between 12 and 15? What is the deviation between 12 and 15? It is minus 3. Clear hai, everybody? It is minus 3. What is the deviation of 15 and 15? It is 0. Then what is the deviation between 18 and 15? It is plus 3. And what is the difference? What is the deviation between 20 and 15? It is plus 5. Clear hai? So it is minus 5, minus 3, 0, plus 3, and plus 5. Clear? Everybody just type yes in the chat box. Super clear this is? So we have calculated the deviation. Okay. Now, can you just take the average? Can you just take the average of this? Now, how do you take the average? Minus 5 plus minus 3 plus 0 plus 3 plus 5 divided by 5. Can you just give me the answer quickly? I just give you the answer quickly. चलो फटाफट गाइस, सीनियर पीपल कम ऑन। कैलसी की जरूरत नहीं है। -5 -3, -5 -3 कितना हुआ? -8 प्लस 0 becomes -8, -8 प्लस 3 -5, -5 प्लस 5 0, so 0 divided by 5. What is the answer of 0 divided by 5? 0 divided by 5 कितना होता है? 0 divided by 5 infinite. Yeah, so let's say it's a 0, right? It's 0. So does it mean there is no deviation? So does it mean average deviation is 0? कुछ भी deviation नहीं है हमारे डेटा में from the mean? Do we have deviation? Yes or no? Do we have deviation from the mean? Do we have deviation from the mean? Yes, we have, right? Because 10, 12, 15, there is a deviation. There is a distance, right? Correct? From every data point, there is a distance from the mean. But why then average distance is coming 0? Because the minus and plus are clashing with each other, and they are, clashing, and they are becoming 0. Are you understanding? Now, to overcome this challenge, statisticians take the square of the deviation. What they do? They take square. Why they take the square? Because square of any value is a positive value. That is the reason they take -5 square, -3 square, 0 square, 3 square, and 5 square. They have taken square of the value. And now they're taking the average of that. So can you just take the average of this? It's like 25 and 9 and 0 and 9 and 25. Can you just take the average of this now? Just add this up and divide it by 5 and give me the number in the chat. It is 13.6. Everybody is getting this value, guys? No, divide by 5. Girijesh ji, just divide this by 5. Average, you have to take the average, right? So this is called, it is called average of the squared deviation. Average of square deviation. Okay, average of square deviation. And this is also called as variance. So 13.6 is called variance and denoted by sigma square. Why square? Because we have squared it. It's the average of the squared value. And because we have squared it, now we have to take the square root of it. Can you just give me square root of 13.6? What is the value? Type in the chat box. Just take a square root of that quickly on your calculator. Square root of 13.6. Some 2 point something or 3 point something aega. What is the value? Type in chat box quickly. 3.68. Everybody got the same value? 3.68. Everybody got the same value? And this is called sigma or standard deviation. Okay, this is called standard deviation. What does it mean? Okay, what iska matlab kya hai? In a very simple language, this is, see, this is not technically right statement, but for our understanding, you can say that for our understanding, for a layman's understanding, it's the average distance of all the data points from the mean. I repeat again, it is average distance or deviation from all the data points from the mean. Just for our understanding. Clear hai everybody? This is called standard deviation. How standard deviation is calculated step by step. So I've given you a formula to calculate standard deviation step by step. Clear? Just type yes in the chat box if it is clear to you. Just take a screenshot of this. Now, you never have to do this manually because we have the statistical software, we have calculators, we have Excel sheets, everything we have. So हमें manually करने की जरूरत नहीं है. But as a Lean Six Sigma practitioner, we should understand what is standard deviation. Okay, so now onwards, it will be very clear in your mind that what is standard deviation and how it is calculated. Okay. Now, what is the unit of standard deviation? Does it have any unit? Type in the chat box. Does standard deviation has any unit? Type in the chat box quickly. Can it have any unit of measurement? No, yes, no. Same as data. What? What exactly? Yes, no, yes, no, yes, no, yes, no. Yes. Okay. Don't know. Yeah, don't know. ये भयंकर आंसर है. Don't know. Yes, very good. So standard deviation has a unit. Okay. Standard deviation has the unit and it has the same unit of your data set. If the data set is in centimeter, standard deviation will be in centimeter. If data set is in meter, standard deviation will be in meter. If data set is in kilometer, it will be in kilometer. It will be in degree centigrade, it will be in degree centigrade. Are you clear? Just type yes in the chat box. So standard deviation has a unit. Okay. And it has, so that means what? This data set, let's say if we take the, if we take the heights of all the people sitting in the room, okay, and the standard deviation is 5, that means from the mean, the standard deviation, on an average, all the data points are 5 centimeters away from the mean. All the data points are average 5 centimeters away from the mean. Clear? Are you clear with this? Super clear? Just type yes in the chat box. Very nice. Very nice. Amazing. Now, look at this. Look at this diagram, okay? Very important for us. What do you mean by N? In statistics, N का मतलब क्या होता है? What do you mean by N? Type in the chat box. Number of what? Number of data, number of samples, right? Number of data points. So if we have 20 data points, my N will be 20. Okay. Let's say if I measure 50 people's heights, my N will be 50. N is equal to number of samples or number of data points under the study. Okay. In this case, N is equal to 23. Okay. What is X bar? X bar is nothing but the average or the mean. Okay. Average or the mean. Now, X bar is generally used for the average of the sample. Okay. Let's say, for example, let's look at this sample and population. We have seen that, correct? So average of the sample is called X bar. Average of the population is called as mu. It is denoted like this. It's a Greek letter, mu. Mu. Okay. Average of standard deviation of the sample is denoted by S, and standard deviation of population is denoted by sigma. Clear hai? So remember this. Whenever there is a sample, you have to mention X bar and S. And where is there if you're mentioning the population, then you mention mu and sigma. Sigma is for the population. Clear, everybody? Yes. Now here, S is for the standard deviation. Now standard deviation is 1.75 in this first graph. Okay. So they have taken 23 data points. X bar is 5 and standard deviation is 175. Now look at this second. Now are you clear with this? Just type yes in the chat box. Ye clear hai? Simple hai. 23 data points are there. Okay. The average is 5. This is the average. And the standard deviation they have calculated is 175, just for our understanding. Okay, what is the data points, etc.? We are not bothering about it. Now, second, just look at the second graph. N is equal to 23 and X bar is equal to 5. Both are exactly equal. But standard deviation is reduced. And look at the spread of the data. It was this much. Now it has reduced to this much. Are you understanding? The spread has reduced. Are you understanding? Yes, yes. Population is the total number from where the sample is taken. Exactly right. You are absolutely right. Okay. Clear? So the second में आपको दिख रहा है standard deviation is reducing from 1.75 to 1.41. and look at the spread of this graph, the bell-shaped curve. It was earlier, it was this much, and now it has reduced. Are you observing this? Just type yes in the chat box. Are you observing? So as the spread is reducing, the standard deviation is reducing. Simple, the average distance from the mean is reducing. Are you understanding? Just think about it. Average distance from the mean is reducing. So the spread is reducing. Yes? Clear hai? Then look at this third diagram. Look at this third diagram. Same number of data points, same average, but it has dropped even further to 0.85. What does it mean? Look at this spread, guys. So earlier it was like this, then it has got like this, and then it has got like this. Are you understanding? So as the standard deviation is reducing, the process, the data is coming towards the center. Are you understanding this? Just type yes in the chat box. Are you understanding this? As the standard deviation, as the process is coming to the center, standard deviation is reducing. Now imagine this scenario. If this is, let's say, this is a specification limit. Okay. If I draw a specification limit like this, imagine this is a specification limit. Okay. What is specification limit? The requirement of the customer. Okay. LSL and USL. Now, anything which goes beyond specification limit is what? Type in the chat box. It's called as what? Anything which goes beyond specification limit is? Yes. It's rejection, it's defect, it's error. Yes, it's a rejection. No? This is called rejection. So this is called a defect. Are you understanding? Yes. Now look at this first data, first graph. More the spread, more the rejection. You remember my first principle? I said more the variation, more the rejection. Yes, and more rejection, more losses. And we are running the company for the profits, but we are making losses. We are making more variation. Okay, look at this. Now it is exactly cut to cut variation. Can you see here? Very small amount of data is going as it is compressing. Now here, there is no data is going beyond specification limit. Are you understanding? So this is where, as we take our process centered and the variation reduced, okay, probability of making defect reduces drastically. Are you clear? Fundamental. And how do we reduce this? By doing the DMAC principle. Through DMAC, our role is to reduce the variation and reduce the rejection, the defects, and save money for our client, for our company. Clear hai? Just type yes in the chat box. And see, most important thing is that in both all these three, the three, what can I say, options, n is equal to 23 and x bar is equal to 5. So the center remains same. The center remains exactly same. Okay. But the variation has reduced. Okay. Variation has reduced. Okay. So this is very, very important. Now let's go to the next one. Let's see. Yeah. Now this is very, very important. Look at this. Imagine. So till now everything is clear. I suppose till now everything is clear. Now look at this. So in the first graph, let's say this is the first scenario where LSL, lower specification limit, is 45 and target is 60 and upper specification is 75. Okay, this can be some diameter or temperature, whatever it is, right? So that is a requirement of the customer. Imagine. Okay. Now I am calculating the process capability. What is that? I am talking about the process capability. Okay, before this, let me just go back to my previous slide itself. In this standard deviation, okay. Now we just have to collect the data from the process to calculate the standard deviation. Okay, right now we don't know whether this process is capable or not. Understand this, huh? Standard deviation is just measuring the variation of the process. That's it. It does not say anything apart from that. Okay. Yeah. See, right now we don't know where is the target. In this process, what we have done, we have collected the data from the process. We have taken the average of that data, the mean, and from that reference line, we have calculated the average distance from each and every data point. And that is what our standard deviation is. That's it. We don't know what is the requirement of the customer. Are you clear, everybody? Just type yes in the chat box. We have not introduced the specification limit yet. Clear hai, everybody? Yes? Super clear? Anybody has a doubt? Please let me know. So to calculate standard deviation, we do not require specification limits. To calculate standard deviation, we do not require specification limit. Now, let's come to the process capability where we require specification limits. Okay. Now look at this. This is where now we are introducing. See, earlier we only had this much, right? Now we are introducing specification limit and we are checking whether my process is capable or not. Okay. Now this is where, now let me draw, before I come to this, I'll go to my whiteboard and let me draw something very interesting. Okay. Now you got to tell me which of the process is a better process. Okay. First, I have the specification limit. This is the target. This is the lower specification. This is the upper specification. Okay. Lower specification limit, target, upper specification limit. I'll just draw this quickly. Lower specification, target, upper specification. Okay. And the third one is same. Lower specification, target, and upper specification. Now try to understand this. The first process looks like this. My second process looks like this. And my third process looks like this. This is my process number 1. This is my process number 2. And this is my process number 3. Now, which one would you select? Which one would you select? Which process would you select? Type in the chat box. Everybody. I want everybody to answer this question. Which process would you select? 1, 2 or 3? Everybody saying 3. ए बाकी के लोग टाइप कर इसलिए आप मत टाइप करो. Why not this much? Why not this one? This is also hitting the target, no? This is also hitting the target, no? And look at this. Look at the spread of the data. Very low, no? This was a good process, yes or no? Spread is very low. And this process is hitting the target perfectly, matching the center. Exactly. So what we are saying is the definition of quality is, write down the definition of quality, write this down. Is equal to hitting the target plus reduce the variation. So in this case, the first process is hitting the target, but the variation is very high. So all these things is rejection, correct? The second process, the variation is very low, but it is not hitting the target. Look at the distance from the target, very high distance. But the third process is exactly hitting the target and the variation is also low. And this is what we are expecting. The quality definition in Six Sigma is hit the target and reduce the variation. And that is the reason we have to measure the central tendency. Hitting the target, that's why we measure mean, mode, median. and reduce the variation. That's what we are measuring, the range variance and standard deviation. Yes, yes, accuracy and precision. Absolutely right. So we want accuracy and precision both. Are you clear? Just type yes in the chat box. How many of you are clear with this? Are you clear with this? Fundamental? Super clear? Okay. So these concepts have to be very, very clear in your mind. Okay. Yeah. Now understand this. I'll just repeat again for Sadanandji. Now in the first process, okay. Now are you clear? This graph is indication of the variation. More the spread, flatter will be the curve. Clear hai? Okay. If the spread of the data is very less, then our curve, the normal distribution curve will be very, very thin. Okay, like this. Correct. So in this first case, you have a very huge, look at this first case, this one. I'm talking about this one. There is a huge variation. The spread of the data is very, very high. So on the right and left, you are creating defect because anything which goes beyond specification limit is a defect, right? Now, in the second case, I'm talking about this one. Now, this process is very thin process, very, very much, what you can say, very close bounded process, but it is out of the specification. It is out of the upper specification limit. That's why everything is rejection. Okay. That's why this is also we don't want. Now we want a process which is hitting the target and having the less variation. Are you clear? Just type yes in the chat box. Sadanandji, are you clear with this? Just give me yes. Okay. Super clear, everybody? Yes? Yes, very good, very good, very good. Super. Now I will go to now this will be the very important point. If you understand this, then you have become 50% Lean Six Sigma expert. Okay. Now listen to me very carefully. Now we have introduced specification limits. Okay. Now, how do we calculate a process capability? The formula of that is the Z-score formula is USL minus X bar divided by standard deviation. Remember this, write this down, the formula. Okay, the Z is process capability number, which is USL minus X bar divided by standard deviation. Okay, now in this case, I'm just giving you some numbers. USL is in this case 75. Okay, so let me write down 75 minus X bar. What is X bar? Let's say X bar is 60 in this case. Let's say X bar is 60 divided by standard deviation. Sigma is, let's say sigma is given as 5. Okay. So I am writing here 5. Can you just calculate this? It is 15 divided by 5 is equal to 3. Are you clear, everybody? So clear hai? What is Z? Z is nothing but the process capability number. Okay, I'll explain you. So when this Z value is 3, that means your process is a 3 sigma process. Write down this formula. Now this formula is applicable when I'm assuming, for your understanding, I'm assuming the X bar is exactly equal to the target. My mean is exactly hitting the target. That is my underlying assumption. Okay, that is my underlying assumption. But this is the formula, USL minus X bar divided by sigma. If my USL is 75, my mean is 60, and my standard deviation is 5, then it is a 3 sigma process. Are you clear? Just type yes in the chat box. Clear hai, everybody? Everybody clear? Just give me yes in the chat box. Now I have just assumed these numbers. How you have calculated 5, how you have calculated USL is upper specification limit. Upper specification limit is simple. Okay. Upper specification limit is simple. Like for example, let's say if you go to a tea stall, okay. Now everybody wants a hot cup of tea, right? Now let's say as a customer, now हम लोग generally नहीं कहते कि मुझे you give me temperature between 70 degree and 90 degree, ऐसे हम लोग बोलते नहीं, right? But So actually in the industry, what happens is that a requirement of the customer is converted into specification limit. Okay. Imagine the hot cup of tea has to be served between 70 and 90 degrees. So 70 becomes the lower specification limit and 90 becomes the upper specification limit. If you give the cup of tea, let's say below 70, it will be too cold for the customer. And if you give above 90, it will be too hot for the customer and customer will reject it. Okay. So you have to deliver the cup of tea between 70 and 90 degrees. Are you clear? This is called specification, lower and upper specification limit, and it will be decided by the customer. Are you clear with this? Just type yes in the chat box. Are you clear with this? Just type yes in the chat box. Super clear? Okay, lower specification, upper specification clear hai? Okay, now the formula of Z is given here. ये standard formula है, इसको लिख लो. Is equal to USL minus X bar divided by standard deviation. In this case, we have assumed 75 as USL. We have assumed the 60 is our mean, which is X bar, and our standard deviation is 5. Okay, so we calculated 15 divided by 5 is equal to 3. When the Z score is 3, it is called a 3 sigma process. Okay, clear everybody? Okay. Now we have done a 6 sigma project on this and we reduce the variation of this process. Now, when I reduce the variation, standard deviation will increase or decrease. Type in the chat box. I repeat the question. Listen to me very carefully. If I reduce the variation of the process, my standard deviation sigma will increase or decrease. Type in the chat box. Think about it and give me the answer. If I reduce the variation, my standard deviation, which is the measure of variability, will increase or decrease. Decrease, but there are few people who are saying increase. Okay, now understand this. Standard deviation is measure of variation. More the variation, more the standard deviation. Lesser the variation, lesser the standard deviation. So if the spread, the variation is decreasing, my standard deviation will also decrease. Okay, everybody clear है? जिन्होंने increase लिखा है, concept clear हो चुका है? Standard deviation is, if my spread is increasing, my standard deviation will increase. When my spread is decreasing, my standard deviation will decrease. Very simple. Clear hai? Now, if I do a 6 sigma project on this and reduce my standard deviation, imagine from 5 standard deviation, I reduce my standard deviation to 2.5. My upper specification and my mean remains same, 75 and 60. Can you just calculate the Z score now? Can you just calculate the Z score? I've reduced my standard deviation to 2.5 instead of 5. So what is the Z score is equal to USL minus X bar divided by standard deviation. So it is 75 minus 60 divided by 2.5. What is the value? Is 6. How many of you got this? When my Z score is 6, that is my 6 sigma process. When my Z score is 6, that is my 6 sigma process. Now look at this. Try to understand this. Try to understand this. Now focus here. Focus here. Something important concept. Now here my standard deviation was 5. Correct? Now from this mean value, from the center, okay, if I plot, if I slice the space into 5 each, okay, so 60 to 65 first slice, 65 to 70, that's my second slice, and from 70 to 75, that's my third slice. Okay, so I can fit one standard deviation, 2 standard deviation, and 3 standard deviation of 5, because my standard deviation is 5. So if I slice the area between 60 to 75, I can slice it 3 times, right? When I can slice this 3 times, it is called a 3 sigma process. That's what we have learned earlier, right? It's a 3 sigma process. Are you clear? Just type yes in the chat box. Are you clear? Just type yes in the chat box. Yes, recording Ashok ji will be there in the masterclass archive. Yes, try to understand this. USL, we don't, USL is decided by the customer. Okay. No, yeah, process KPI also can decide. Yes, it can be internal. It can be internal. Now listen to me very carefully. Listen to me very carefully. Have you understood this calculation of 3? Just type yes in the chat box. ये calculation समझ में आ गया? Just give me yes. First वाला sample. Clear है? Okay. Now just stick to this. When my Z score is 3, okay, that means so I understand this. My standard deviation is 5, right? My standard deviation is 5. The distance between my mean X bar and USL is 15, right? Yeah, 15 is distance. 75 and 60 ka distance. What is the distance? 15, right? So I can slice this distance of 15 3 times. Yes or no? Okay. So 60 to 65 because my sigma is 5. So I can adjust, I can fit 3 standard deviation between my mean and my USL. Yes or no? Because my sigma is 5, my distance between my USL and mean is 15. So I can fit 3 standard deviation between these two, right? Everybody got it? Just type yes in the chat box. If I can fit 3 times standard deviation, it's my 3 sigma process. How many of you got it? Bulb-on kiska hua? Bulb-on. Just type BO in the chat box. It's called bulb-on moment. Dimag ki batti jal gayi. Bulb-on. Okay. Now, similarly, now here, look at this. Similarly, now my standard deviation is 2.5. I can fit 6, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5. I can fit 6 standard deviation between my USL and X bar. That is my 6 sigma process. So 1, 2, 3. Got it, everybody? 4, 5, and 6. Because my standard deviation is only 2.5. So I can fit 6 standard deviation between my upper specification and my mean. It is called 6 sigma process. Got it? Bulb-on, super bulb-on. Okay. Now, which means, see, on only one side, when I say 6 sigma process, only one side I can adjust 6 standard deviations. So in total, between LSL and USL, I can fit 12 standard deviations. When it is 6 sigma process, between upper specification and lower specification, I can fit 12 standard deviation, 12 slices of standard deviation, because my standard deviation is so low, because I have just, my spread of the process is so low, my standard deviation is very little. I can fit 12 times between my upper and lower specification. So imagine a process which can even go, wander here and there. Still you are making money. Still you are making money. If your process is so slim, still you are making money. If your process is fat, if you go a little on this side, you have lost money. If you have got this side, you have lost money. If you're slim, you can go to anywhere between upper and lower specification like this. And still you are making money. Your customer is happy. You are happy. Management is happy. How many of you got this, guys? Super clear hai ye concept. And that is the reason through DMAC, through statistics, through Six Sigma, our only focus is reduce variation and earn money. Simple. Everywhere, reduce variation and make money. Lot of money we are wasting because of the variation, because of the rejection, the rework, cost of poor quality, customer complaints. Everything is because of the variation. Reduce the variation, you will make money. And if you become a consultant like us, you can ask certain percentage from the saved money and become rich. Okay, superb. So I think that's it from my side, guys. It's already 9:10. So I'm open for the question and answer. So this